Hello and welcome to the show. It's Jess here. Funny story. So I went to do some work on the podcast this afternoon. It's a beautiful Sunday afternoon, and I realised that I missed the last scheduled release date on the 8th of December. I have no excuse. I am very sorry if you were waiting for your episode to drop on the 8th of December and you are upset with me. I offer my sincere apologies, but here is the episode now for you. It's an interview with Pete Raimondo and Shawn McIsaac from Oculus Engineering, and they are a facade engineering company based out of New Zealand and now Canada as well. They're two super knowledgeable guys whom I first met at the very first building physics conference I ever went to back in 2018. So hope you enjoyed the chat. Also, please leave a 5-star review on your listening app if you're enjoying the content, and also hit the follow button so you don't miss a future episode, particularly if I miss a publishing date. Oh, and one more thing is that there will be another episode in 1 week instead of 2 so that I can catch up with my usual publishing schedule. So this is the second last episode for 2025. I've got one more left for the year. I cannot believe it's been nearly a year of the Building Sociology Potty. Thank you so much if you have been following the show from the beginning. Your support is absolutely invaluable and I've had so much fun. But I shall do a wrap up next week. Thanks again and enjoy this conversation. Hello and welcome to the Building Sociology Potty, where we talk about better buildings to live and breathe in. Today on the show, we're joined by two experts who literally know buildings from the inside out. Shawn McIsaac and Peter Raimondo are the co-founders of Oculus Limited. They are leading specialists in building envelope design, energy efficiency and building science in New Zealand, though Shawn has recently taken Oculus International after a move to Canada with his family. They work with builders, architects, engineers and certifiers to ensure what is designed actually performs the way it's supposed to. From condensation risks and thermal bridging to practical install info and junction detailing for builders, their work focuses on translating building science theory into buildable solutions. So builders who care about better building, you're in the right place today. So let's get into it. Welcome, Shawn and Pete.
Thank you.
Thanks for having us.
So you guys have started your own podcast. Tell us a little bit about it and where we can listen.
Yeah. Long story short, if you pop on our website, obsf.co, you'll find all kinds of resources and things like that. You'll find the links to our podcasts and whatnot. But also on our Instagram account, we have like little clips and things like that. That's obsf_engineering. And just, search that up. But
YouTube channel as well is up and running.
Mm-hmm.
Same handles, I think, OBSF Engineering.
Awesome.
Really, it started because we were seem to be answering the same question over and over and over again. And so instead of answering people, we're just going to direct them to the links.
Yep.
And also it we didn't have email. There was you've been doing some stuff on sort of refer exactly. So we've got some real basic intro to building science stuff on there, and also some longer form stuff where we talk back and forth with Peter and myself. So if you like building science and you're sort of nerdy like that and want to listen to a podcast about it, there's a place for you.
Yeah, you can also watch
another place for you, I should say.
Video and audio, so you can see it. But we do have like two different flavors. One is like each one of us individually speaking about a topic, and then the other one is us kind of sitting next to each other and chit-chatting back and forth. And we'll probably continue that with other people in the industry, other people in our company, et cetera, et cetera. We've only done, a basic amount to start uploading, and then we'll keep going from there. And if you have any requests, let us know. If there's any topics that anyone's wondering about and you just don't have any local knowledge or local resources to rely on, give us a shout and we'll do a little bit of research for you if there's something that we don't know about, and we'll talk about it.
Awesome. I will put all of those links in the show notes for anyone who wants to find you so that they can find you nice and easy.
Lovely.
And get on it. These guys, they know what they're talking about. So let's get some background first up so the listener knows who we're talking to. A bit of history on your careers, please. Shawn, would you like to go first?
Yeah, certainly. So I started off my my college career in engineering and didn't really know what I wanted to do. And I did a Google search for summer job, and this place called RDH popped up. and I sent them an email and ended up getting a summer job there. And they kind of specialize in probably lead North America in building science. And that was 17-ish years ago. And I kind of kept doing it. So I spent about 7 years in Vancouver doing that, a couple years in Seattle, and then moved to New Zealand in the run up to the Trump election, the first one. 2016 is when we moved from Seattle to New Zealand. And just recently in 2025, we've moved back to Canada and starting an office up here. So started Oculus 7 years ago, it was, in New Zealand, to 18 people now. And we just focus on building enclosure, building envelope, building science for medium-sized buildings across New Zealand and BC, Vancouver area.
Yeah.
Awesome. Pete?
I'm up next.
Yep.
I started in Toronto, so like colder part of Canada. Did a civil engineering degree at U of T, then graduated, worked in construction for a little bit. Didn't know if I wanted to be in engineering anymore because I had like a bad experience with a job. Went to Europe for a while to find myself, came back, did some singing and barista stuff, and
Wow.
then eventually got myself back into the engineering game, into forensic engineering. So like inspecting burnt down houses, houses with big leaks, and remediating them. And then from there, started working at another big firm called that starts with an R, not RDH, it was RJC, which does very similar stuff. Less of a leader in the building science zone, but a leader in doing all the remediation type stuff, and lots of contract admin stuff. Then eventually wanted to move somewhere and decided that New Zealand was the place I wanted to go, and then applied for a job with Shawn, and he said if I wasn't a serial killer, I was hired because of, I guess, my resume or something. And the rest is history. It kind of went well from there.
Awesome. So you applied for a job with Shawn. You both founded the company though, or you applied to work with Oculus?
Yeah, very, very soon after Oculus started. It was only a company for like a few months, and so like I was there.
Okay. So
Very much.
co-founder is kind of sort of accurate. You kind of been there since the beginning, right?
Yeah. Been there from the beginning, but
Technically
yeah.
not, but
Yeah.
About it. That's the truth.
Yeah. Cool. So that work you did in the remediation space and forensic space, that's pretty cool. You learn a lot about how buildings fail and how not to fail
Very much
in that
so.
kind of
Yeah.
work. Yeah.
Spent a lot of my building hanging on the outside of building on ropes on little chairs and poking at sealants and spraying water at stuff and trying to
Yep.
figure out what leaks happen and make sure they don't happen again.
Yeah, cool. All right. Well, thank you very much for that, guys. So, Shawn, you're in Canada right now. Pete, you're still in New Zealand.
Yes.
You're both in the leaky building hubs of the world right now. We've got the leaky building crisis in New Zealand, the leaky condo crisis in Canada. What do you see in the existing building stock or still happening in new construction in regards to this multi-billion-dollar disaster, both of them?
well, actually, you're sort of in the hub of it too. You guys just don't realize it yet.
Oh my God, I know. Don't worry. We just haven't had a number put on ours yet, but it's happening.
Yeah. So we know that stuff happening in Australia that's very similar to what's happened in Vancouver and New Zealand, and we'll wait our time and the right opportunity will come up, I'm sure. But I mean, what we try to talk about disasters and we try to talk about changing building codes, and someone once told me that building codes usually change as a result of a disaster. So you have to wait for something catastrophic to happen before a building code will change. And so you see things like Greenfell being an example, and more probably closer to home is the Docklands fire in Melbourne. As examples of disasters which cause some sort of change in the industry. And so it's hard to see that you're really anything else is changing at the moment. But I think with some of the increasing insulation values, you're starting to see some problems pop up, which are very similar to what leaky condos and leaky homes were. And we could avoid all of this by using science. Is what science is supposed to do is you're supposed to be able to predict and use principles and physics and tools we have available to try to avoid these sorts of things. And I don't know, we're seeing that on the the mainstream yet. You're seeing people, experts on the cutting edge of things, sort of raising alarm bells or being Chicken Little and saying the sky is falling, and eventually one of us will be right. Um,
Chicken
Yeah.
Little.
don't know
I
which
like that
don't know which side.
analogy.
Yeah, I feel like there's a lot of things that are even being built today, and because, there's some gaps or discrepancies or lack of coordination between different building code clauses and things like that, we're still seeing things built that eventually probably will have some issues, whether they are actual leaks and water coming in, um, or condensation, interstitial condensation, like Shawn was kind of referring to there. But I find that there's a lot of situations, at least here in New Zealand, where there's a lack of, I don't want to say oversight because that's not quite the right word, but a lack of maybe construction monitoring. Like the design might be pretty good, but then once it goes into construction, sometimes there's a little bit of guessing going on and not a lot of kind of feedback between the design team and the construction team. And I don't think it's anyone's fault necessarily. Everyone's trying to do their best. Everyone's trying to build things, but I feel like there's just a lack of knowledge, maybe a lack of kind of acknowledgement of certain things that need to be put in place for redundancy to make sure that even if there are mistakes on site, then it doesn't become a big problem later on that's really expensive to fix. But basically, just redundant systems that allow things to drain without causing damage to things
Yeah.
on the inside of that. So, yeah,
Yeah.
that's
To Peter's point, like you don't see a lot of bad designs or bad drawings. It's really hard to see, even in buildings that failed, like leaky condos. You can look at a set of drawings and say, "Oh, this looks fine," but it's usually not where the things go wrong. It's usually things that don't show up on paper, especially not in
yeah.
2D.
I've
And
never actually heard. I mean, there's this thing that we refer to called the performance gap, which is what's designed is not what gets built. And
sure,
so, what you're talking about is that right there, and it's why I moved over into the passive house sort of as built verification side of
sure,
construction because it's something
sure.
that you can trust. Um, so, well, what you said there is, yeah, you don't see things go wrong on paper, generally speaking.
Yeah, and to kind of flow on from that, it's like the design is in theory pretty good, but sometimes maybe the design doesn't take into account the realities of what actually happened on site and the fact that not everything is built perfectly. And so you have to design with that in mind that it's not going to be perfect,
Yeah.
perhaps.
Yeah, definitely. And we do lots of, education for builders about this and also architects and sort
Yeah,
of building in lines of defense and
sure.
communicating with builders and all these sorts of little things,
Yeah.
little changes in their process to
There's
try
got to
and,
be feedback back and forth
yeah,
between everyone so that we're all aware of what our own limitations are and what everyone else's limitations are so that we can, make a building that works.
for sure.
You brought up that performance testing aspect. I think that's a pretty key one actually, because you talk about air tightness testing is a great example of something where you could build it exactly as it's drawn, and
Mm,
you could get a range in values from zero point 0.5 air changes per hour to 5 air changes per hour, depending on just
Yes.
who's paying attention or what they're doing on site.
yep.
I've don't know if I said this on podcast or not, but the difference between 5 air changes and point 0.5 air changes is a roll of tape and giving a fuck.
Yeah.
You can
Yeah.
it's not there's not a lot different in terms of details or effort or anything. It's just sort of understanding what you're doing and sort of caring about it.
Yeah.
Yeah. A
And
little bit of
and
intention
sometimes
goes
it's
a
just
long way.
knowing you have a test coming brings you down into those
Mm.
higher performance numbers that you're seeking. So
Um, I have clients even coming to me saying, "Oh, we want to do this, and we want to go for an airtight build, but we don't want to do a blower door test." And I'm like, if there's any intention to do anything airtight, you need to know what the outcome is. You really need to know that.
Yeah. And I
Uh,
find that
this,
it, sometimes people are scared of that airtightness test because they feel like they're going to fail or something like that.
yeah,
And sometimes we've had certain projects where we haven't had an airtightness rating that we're aiming for, no certification that we're going for, but we'll still suggest, hey, let's do an airtightness test. Maybe it'll get us a couple points from Homestar, Green Star, one of those certification schemes where you get a point just for doing the test, not for getting to a certain level. And what we find is that the contractors learn a lot and see it as not scary and more of like an, oh, wow, I feel air coming in from here. Maybe I can detail that better next time. Oh, there's air coming in from there. Maybe that's something that we can put more tape on or figure out a different way to do. It's a learning experience, and it kind of gets rid of those unfounded fears, because sometimes it seems scary to have a test because you're in school.
Yeah.
Oh, I'm going to fail my test, but
Pass or fail. Yeah.
yeah,
Totally. All the trades that I've shown who have been new to blow testing, they've all loved it. They've all thought it was
sure.
fascinating.
Yeah. Every single time we've actually done one on site, everyone's like, wow, this is really cool, as opposed to being really angry
Not
about it or
scary.
something.
Yeah.
Yeah.
The quality builders are the ones that are interested in it. Because
Sure.
Yes.
sometimes what I tell people too is that a blower door test by itself is not necessarily that useful of a information
Sure.
about the building.
Mm,
But what it is a really good proxy for quality.
mm,
Uh-huh.
Because very rarely you have a high quality builder build an air leaky home. And the flip side is very true. Like if you have a very airtight home, it's probably well constructed elsewhere.
yeah,
Yes.
S-
Spot on.
indeed.
So how can we speed up this learning? How can we take, you said before that, the sky's falling, Chicken Little. You've got Canada, you've got New Zealand, you've got what's going on in Victoria and Australia and elsewhere in Australia. There's lessons being learned left, right, and centre, but still the industry at large is not really changing. So what do you think we can do to speed up this learning and stop us repeating the same mistakes?
It's a good question. It's a very good question. We've kind of tried, at least here in New Zealand, to try to spread knowledge into the industry by, doing podcasts, releasing, different written articles and examples, and going out to universities to do lectures, or going up to architects' offices, or going to the councils and with their building inspectors, maybe having conversations or doing full presentations. And that is a good step to try to expose people to things that they might not have been exposed to, and try to at least get them asking questions that they might not have been asking before. That's at least the first step. Um, but it, it it doesn't really magically change everything all at once. But I have seen, since I got to New Zealand, 6.5, almost 7 years ago, I've seen a gigantic improvement in people asking the right questions, people, not being scared of some testing, air tightness testing, water testing on site, councils starting to ask for those sorts of things. The questions, RFIs that we get from council are starting to, get towards there. But I think a lot of it, unfortunately, does have to come from the central government or from the state governments changing the building codes. And that is generally the slowest thing to happen, because usually, like
Slow
Shawn
burn.
said, it's disasters that change the building code. And so it's that's not an excuse to say that we have to wait for government to do it for us, because that's not really a good excuse. We all have to try to do it together. But to pick up the bottom end of the industry, there's not really much else they can do unless they're incentivizing better schemes. And so if people don't just follow base building code, they get some sort of advantage, some sort of financial something for doing a little bit better. Maybe that's the answer. There's been a lot of
Money
different
always
ways
talks.
done around the world, and we can just look across the world and see what's worked and what hasn't, and try to emulate that in our own industries potentially. But not sure if Shawn has any additional kind of thoughts about it.
Yeah, there's a pretty good case study, if you will, or example from Washington State, just below
Mm,
British Columbia, the top northwest corner of the U.S. They brought in voluntary air tightness testing in mid 2000s, like
mm,
2010 ish range. And the first, I think, 3 or 4 years, there was a requirement, a voluntary requirement to test the building and tell us what the number was. There was no benchmark to hit. It was just do the test and just tell us what the number is. And by about the third test, each general contractor was pretty competitive at that point,
mm,
because
That's what happens. Yeah.
they would tell their buddies like, "Oh, our building got a 3, and oh, we got a
Mm.
2.7 on ours." And
mm,
once you get
Yeah.
that sort of arms race happening, you've got some pretty macho bros. They're all got a lot of pride behind them. And so
Mhm.
if you can get that sort of, that's where the competitiveness comes in, and like I said earlier, that's a measure of quality. So if you are
Mm-hmm.
now, if you're at the high end builder, you're gonna start promoting how high a quality your builds are
Hmm.
by using
Mm-hmm.
that as a number. And once the industry sort of the public start to understand what that means and why they want an airtight building, that'll start
Yeah.
to drive some of the change.
Mm. I'm also wondering if it's worth, because right now there's not necessarily a lot of I guess, interest or desire, or like the general public doesn't necessarily know what a high quality building is. I'm not sure how it is in Australia, but in New Zealand, a lot of people really prefer older buildings, the old stock that was built in, the early 1900s. It's beautiful, good bones, stood the test of time, and I have to understand that, and I agree with
Mm-hmm.
them. Um, but then once you kind of move to more airtight, double glazed windows, there's a lot of news articles that come out saying, oh my gosh, they're overheating, and kind of blaming it on the newness of them, as opposed to the fact that overheating wasn't considered in design because the building code didn't say that you had to.
Mm-hmm.
And so kind of educating the public and getting them on board with asking the right questions to a builder, to a supplier, saying, hey, I want this for my house. And as a North American coming from Canada, I'm used to a house that is generally a maintained, consistent temperature year round, whether for good or for bad. But here in New Zealand, it's not like that. And since becoming a Kiwi, like I get it. Like I want the windows open during the summer. I want that indoor outdoor flow. I get it. But I also want to be comfortable in the winter. And I'm not sure if everyone's kind of on board with that yet. And so maybe
No,
that's also part of it.
it's a very common experience. This year on the social media, TikToks and things, it's sort of the trending thing is, you know, you come inside in an Australian home in the winter and you put your jackets on. It's colder
Hmm.
inside than it is
Hmm.
outside. That's been a real trend this winter
Same here.
online.
Yep.
So on that, there's a big there's a push for retrofits. There's a push for making existing stock
Sure.
warmer. Um, you were talking about incentives. So in Victoria, I think it was in Victoria, in Australia anyway, there was some recent government incentives, government programs where they were going around insulating roofs. And I think that was in Victoria and some in South Australia as
Like
well. I have to check.
for
But
free, subsidized? What are we
yeah, so
talking?
the government was paying for insulation to be put into. There was some requirements that had to be met, but they were paying for insulation to be retrofit into existing homes. And wouldn't you know, it caused mold problems.
Hmm.
Um, so good intentions, really
Sure.
bad outcome.
Sure.
Then there's another one happening at the moment that I've read about on LinkedIn where they're doing it again, but this time they've taken into consideration the science behind it and being more careful about it. So
Okay.
one can only hope they've asked the right people in Australia, and one can only hope that this scheme is more successful. But
Yeah.
one of your social media posts this week was about retrofit, so I'd like to touch on that. Yeah, so insulating old buildings is popular. We want to increase the energy efficiency and comfort of those beautiful old homes with the good bones. But what is the biggest area of risk when retrofitting an existing building, and what can be done to reduce that risk?
Sure. I'll let
Yeah,
you take.
so roof is probably the most risky. If you had to choose one, it's probably the riskiest spot. And the primary reason of that is night sky radiation. If you're not familiar with that term, it's the fact that when you have a clear night, you lose more heat to space, which sounds insane, but it's true. It's probably like a 4 or 5 degree difference, something like that, which is enough to make roofs higher risk than walls.
Mm.
Now, if you have a completely uninsulated roof with zero insulation, your attic space is going to be the same temperature as below, or very close to your living space. Let's just say it's 20 degrees, it's probably more like 16 or something in most of Australia. But in your attic space, let's call it like 16 degrees. Um, and when you add insulation, you're blocking all that heat gain from below from reaching that attic space. So now you might have maybe you get a bit warmer below, 18 degrees, but now your attic space is cooler, like 10 degrees Celsius.
Mm.
And so now you've got a problem where dew point in much of Australia, especially at coastal climates, dew points are going to be or above 10 very, very frequently. So now you just increase the amount of condensation events that occur. and reduce congestion drying. And whether that balance gets tipped to the spot that it's a disaster or a problem is like, I don't know, you're sort of you're
Up to the whims of
playing
the
with,
weather.
yeah, you're playing with fire,
Yeah,
if you will.
yeah,
So that would be just, and every building science person should know this by now.
yeah,
Now,
yeah,
we'll give some caveat here that probably 20 years ago, when insulation started increasing in these roofs, even the best of the best in the Vancouver, Canada, sort of didn't get this right. So it was a problem that didn't pop up, or at least not in the mainstream, where there's probably some nuanced people that sort of saw this coming. Um, but this is the opportunity for Australia and New Zealand to learn from those mistakes and maybe put in some mitigating circumstances, or some ideas, or maybe that's not the best idea to insulate some roofs for
yeah,
the energy payback. So
yeah.
some lessons learned from elsewhere could save a lot of problems.
Yeah, and I see why people want to insulate a roof because it's easy. You just pop through a hatch, toss a bunch of
And cheap.
insulation in there, and you're good to go. There's also people who say, oh, as long as you maintain the amount of ventilation in that attic space through the eaves and through the ridge, you're good to go. But there are studies from it, like Vancouver especially has a lot of studies on that. But even I'm pretty sure Brands in New Zealand also has some studies on that, showing that no matter
Several.
how much airflow you're getting through there, because the outside air is so humid and your dew point temperatures are so close to that air temperature, you're probably going to get condensation and mold growth anyway, no matter how much ventilation you go through there. Unless you're heating that air up as it's coming in and then using it for drying, it's not just magically going to fix itself. Um, and so in the article, because we had our social media post, but that relates back to like a full on article. I think we were saying that the first thing you should think about is heating and ventilation first, because heat kind of cures a lot of things, gets rid of a lot of condensation risk. And then ventilation also gets rid of, all the air we breathe out that has heaps of moisture in it, showering, cooking, etc. Using that ventilation to stop the moisture flow first. And then when you're going to insulate, there's not really like an easy, oh, just put this insulation everywhere and it's all good. There's not a one good answer. It really depends on the historical use of the home, how it was meant to be heated, ventilated, and insulated, and then making sure that you're not causing dew point issues, interstitial condensation issues, by adding insulation in there. Because insulation is great at keeping us inside nice and warm, but it also does the same thing by keeping the external surfaces colder. And that's something that, is a little bit counterintuitive. Maybe you don't necessarily think of it, but by putting insulation, you're making yourself more comfortable, but you're making your building less comfortable unless you have airtightness, you have ventilation, you have heating, you have drainage pathways, et cetera, et cetera, et cetera.
It's time for a quick sponsor shout out. Today's episode of the Building Sciology Poddy is proudly brought to you by our amazing sponsors, Enduro Builders and Climasure. A huge thank you to these incredible businesses for supporting the podcast and helping us spread the word about better buildings to live and breathe in. Your support makes this podcast possible. Please head over to their websites and follow their social pages. So is there a safe way to insulate an existing roof? And I know this is a it depends question. It depends on how much space is up there. It depends on the behavior of the occupants. But is there a safe way to insulate an existing roof, and how does that differ from a new roof?
Good question. Good.
So I think when you
Still
look
on that
at
one,
some
are
of
you?
when you look at models of roofs and try and run hydrothermal analysis and WUFI models for roofs, somewhere around R4 seems to be the spot where things start to break down. So you can get away with insulating a roof up to about R4, maybe 3.5, 4, depending on climate, sort of thing. But so if you wanted to just go to R4, you're going to have more dampness in that roof, but probably not to the point it causes like catastrophic moldiness or decay.
Yeah.
When you start going like R6.6 or 7, which is what we're doing in New Zealand, the WUFI models go haywire. Just they
Yeah.
really they look pretty ugly.
Mm.
Um, so what I mean, we could do a whole podcast just on warm roofs, but
Yeah, I know.
yeah, moving the insulation above the structure is really the only answer.
Yeah,
Um, and it's sort of the best building science answer, and sort of where a lot
Right.
of
Yeah.
the end game is going in, certainly in Canada. New Zealand is probably pretty close behind.
yeah. And it's a little bit complicated if you haven't done it before, but if you know kind of some tips and tricks, if you know some suppliers that have the right materials and right fixings and things like that, it's pretty easy to externally insulate. So for instance, for a roof, a few of the suppliers, at least here in New Zealand, I'm not sure if they offer it in Australia yet, they have like re-roof type situations where you have your corrugated metal roof. They put some little strips of insulation in the corrugates and then put a flat piece of rigid insulation on the outside of that, and then a new roofing iron on the outside of that. And that works pretty well because it gets rid of that night sky radiation. It
Oh,
keeps
so
your
you literally
attic
just put it on top.
comfortable. Yeah, yeah, yeah,
So it's such an awesome roof, actually.
yeah. You have to
Really
Wow.
have
good.
capacity structurally to make sure that all works out, but
And like heights
most
and things
times
as
it's
well
easy. Yeah, yeah, yeah.
in the
But it's only what,
cities.
70 mils, 80 mils. You
Yeah.
get an exception pretty easily from council if you ask nicely.
Interesting.
It
Yeah.
depends. Yeah.
We
Yeah.
have this weird thing in Australia where warm roofs get the definition gets muddled up.
Sure.
So I've called them the Aussie warm roof and the European warm roof because in Australia we think that a warm roof is where the insulation is at the top the top of the top quarter of the truss
A
in
skillion
between the
roof.
trusses.
The Skillion roof,
Yeah, or
yes.
even a flat ceiling with, a truss ceiling,
They just
a
pin
truss
the
roof,
insulation
sorry.
up there.
They just put the insulation up there to
Mm,
keep the
okay.
like ducting warm and
Sure.
things like that. So that's what a lot of builders in Australia are doing.
Sure.
And so I had to differentiate. I did a post about it. I
Sure.
differentiated between the two types because
Yeah.
I was like, the terminology is important here, guys. We need to understand
Mm,
what we're all talking about. And what
mm.
you're talking about is the European warm roof, where the structural members are kept warm, where the
Yes.
insulation is on top.
Yes.
Yeah.
Exactly
And I
that.
think you can do that safely with a truss roof, can you? Where there's a roof void still?
Usually, yeah. Yeah. I
Yeah.
mean,
Yeah.
there's
And
certain
that doesn't
circumstances where it wouldn't work, but yeah.
And that and then, yeah, the roof ventilation thing here has gone crazy as well because there's all these changes in the building code around ventilating roof spaces and the climate zones that needs to happen in. And
Sure.
the builders
Sure.
are like, just tell me what I need to do because they're also
Yeah.
confused.
Yeah.
Um,
And
it's
I feel
complicated.
like part of the issue is trying to oversimplify or trying to give someone an easy answer. And unfortunately, when we're working at this level, there's not really an easy one fits all like answer that works, one size fits
Mhm.
all kind of thing. So yeah, it really depends. But external insulation on the outside of walls, on the outside of roofs, on the underside of your slab, that usually works pretty well if you can
Yeah.
get it built that way.
Yeah.
Here in New Zealand, there's one of our former colleagues that is did a master's program on externally insulating like old villas with weatherboards and things like that, and trying to find a really quick, easy, simple retrofit that allows people to stay inside, like living in the house, while also putting new insulation on the outside, which is pretty cool. Not sure if it's a thing that Australia might be eventually interested in, but could be.
Yeah. Well, often external insulation just gets parked because it's too hard.
Sure,
In a retrofit situation, there's plumbing and there's
sure.
windows and there's all this crap that we can't work around. So if there
You
was a
can.
solution to that, then
They can. They just don't want it. It's just new.
yeah,
It's all
yeah.
doable. Yeah, just new.
If you have some information on that, your friend's research, that'd be cool. We can put it in the show
It's
notes
it's
if
Parka
it's
Wrap, by John
Parker
Dave.
Wrap. Yeah, yeah,
You've heard of
I
it.
know the one.
Yeah. Yeah.
John in New Zealand.
Yep.
Yeah, yeah, yeah. Awesome. I shall link
Yeah.
that in the show notes.
Yep.
Parker
Definitely
Wrap.
do.
Yeah.
Mhm.
Excuse me. So, what is a pet peeve for both of you that comes across your desk?
For
Just
me,
one. Just one.
I'll take it first, and then I'll let you finish, Sean. For me, my
Sean's like,
biggest
where
pet
do I start?
for me, my biggest pet peeve, I think, the thing that really grinds my gears is when I have come up with a way to simplify and reduce the cost of a building. And just like, oh, you have all these extra pieces of concrete and timber and frame and this and that. If you just have a slab and put a sloped insulation on top of that, this is just one example, it'll save you a lot of time, a lot of money. It'll be a much better building because you have external insulation as opposed to like this void space that's just middle of nowhere. But I get told no because it's different and therefore it must be too expensive. Even though I'll cost it out, I'll do all the sizes and the square meterage and stuff like that and say, price this, please. Yeah, that's the biggest thing that is my pet peeve. Because like I'm trying to do my work, I'm trying to improve, I'm trying to help them, I'm trying to save them money. But then I get told no because it's different. That's probably my biggest one. Shawn?
Okay.
I have so many that I've probably just become, I don't know what the word is, disillusioned by it. Like your point there, Peter, about suggesting an awesome alternative or a cool way of doing things, and nobody wants to entertain it is frustrating. But I think after you've done it enough times, I sort of gave up on caring about that sort of pushback 5 or 6 years ago. So
Sure.
I mean, when I'm working on projects, I'm really just giving people advice and ideas, and if they like them, then great. If they don't, then that's fine too. And
Yep.
usually those ideas get caught on the next project, the project after, or you come back to them. What was that cool thing you were talking about doing? And so
they won't accept it straight away. That happens to us a lot too.
Yeah.
I don't get too caught up in that.
Down the track, they'll come back to you and go, what was that again?
You mentioned that
I need
thing.
that.
Yeah.
Yeah, and trying not to be too hyperbolic about the risks of what's currently drawn or what the way it's always been done. It's just, you might have some condensation in spots, or you might have this, or whatever the issue may be. And if you're willing to live with that, then fine. As long as you got the information.
Yeah, I try to come into a meeting with that kind of, perspective. Just like, hey, this is going to be condensation. And someone will be like, it's always been built like that. But what I try to, I guess, reiterate is the fact that if there is condensation, it's the reason when you walk into an older building and it's kind of just like a little bit stinky, just like kind of feels musty and stinky. That's because of condensation. And so if you don't want that, do it this way. If you're okay with that, then hey, fill your boots, do whatever you want.
Actually,
do you ever get any?
I do have a pet peeve, actually. I've come up with one.
Oh,
what is it?
Go.
So when I start on a project, I always feel like I want to be part of a group of people who know a bunch of things, which are now creating this new building. And so you're like, let's assemble a team of experts and design this, try to get to Mars, right?
Sure.
Like no one's ever built this particular building before. So you've got some expertise there. You got some expertise. You got some expertise. And you would think that then you would all like work together to find the best solution or whatever. And sometimes project teams, you get factions or siloed. Like, I'm building this building. I've already designed it. And this is the HVAC system, and you need to deal with it. And this is how we're doing the structure, and there's no way to change it. And so then you're like, well, what are we doing here? Like,
why are we here?
I thought we were designing something. I thought we were building something. If you just wanted to build the same building from last time, then you should have told me that.
Yeah.
So you guys start to wonder, like, if you get pushback, Pete, on your alternative solutions, and Shawn, you get told like, well, this is the way we've always done it, so this is the way we're going to do it. You end up thinking like, why did you ask me then?
Why am I here? Just decide a piece. Yeah. Okay. Cool. Thanks.
Yeah.
You could have told me that.
More than one way to skin a cat, but you're like.
Does anybody think the last building we built was the perfect building? Like, there's always room to improve on things, right?
Yeah.
So
yeah.
So that
and
some
does
of that
anyone
design
think that
arrogance
the tick box exercise of the code is, the only way to go?
Yeah.
Yeah.
It is what it is.
Yeah. Yeah. Do you have a number one detailing issue that gets often messed up on site?
On site.
So for energy efficiency, it's where a 2D detail has a rafter or joist coming out over a wall, and in the 2D detail you can't pick it up. Or calm floor, like corrugated flooring is the other one, where the 2D detail doesn't show it actually got holes in it. So that's
Mhm.
one that
Mm-hmm.
I've started to look for because it's really hard to pick up on paper if you're not looking for it.
Yeah.
Corrugated flooring.
Like
Like
corrugated
corrugated
metal deck with
steel.
a concrete slab on top.
Okay.
You wouldn't see that
That-
in low rise,
Is
but
that not a thing
in
in?
No.
not
Okay,
in
fair
low
enough.
rise, no.
Yeah,
Yeah, no.
bigger mid-rise, high-rise buildings usually have them because it
Yeah. Yeah.
speeds
Fair
things
enough.
up.
Yep.
Um, but on site, I find it's usually like Shawn said, just a lack of caring. Like I'll go on
Mm.
site and go look at, a tanking membrane, a waterproofing membrane. And the guy who installed it is like, yeah, it's perfect. There's nothing wrong with it. And then I go and I shove my whole arm through a hole. And he's like, oh, there's that. And I'm like, oh yeah, like it has to be sealed. Like, what are we doing here? Like, did you not
Yeah.
check? Did you not send anyone through here? It's just little bits and bobs like that that
Yep.
are kind of frustrating.
Mm.
Um, and then like Shawn said, just stuff that doesn't show up on the details on
On
the
paper.
drawings because it's just a one-off detail in this one random corner. And when it's up to the guys on site, they're doing their best, they're trying their best
Mm.
based on the knowledge that they have on the previous jobs, but sometimes it's not similar to anything. And then it's nice when we catch that, give them a little detail, say here, do it like this. But sometimes it's already done, and then we have to go try to find a way to rip things open without wasting too much money and make it work. So
Mm-hmm.
I'd say that's probably the
Something
biggest thing.
something I found in the Vancouver, BC region, which I didn't necessarily get the same vibes from the New Zealand industry, was the applicator's understanding of why they're doing something a certain way. So
Mm,
why are we putting
Yep.
peel and sticks on this way? Why are we doing an air seal? Like
mm,
the installers in Vancouver, they would tell you what they're doing. Like, we're
yes,
gonna do it this way because your detail sucks and we want to do it this way. And you go, yeah,
yes,
it's a much better idea. Whereas, the guys in not everyone, but a lot of the New Zealand industry was there. I'm gonna put this on the wall and I'm done my job, and they don't actually understand why they're doing it. And
See,
so
it gets even worse when you come to Australia. 'Cause
we've heard.
like, we know we have, New Zealand trades that pick apart Australian details.
Mm,
So, from Vancouver to New Zealand and then New Zealand to Australia. So, and then I think even South Australia, I've speaking to a building certifier recently who informed me that the rules in South Australia are even looser than they are in other parts of the country. So, yeah.
yeah, I find not to put blame on anyone else, but I feel like there is room for improvement from suppliers. In Canada, I'm from Toronto, not from Vancouver, but like in Toronto, you email a supplier and they will give you an overabundance of information. They will solve problems for you. They will write specs for you. They'll do a whole bunch of extra work. And I find that here you have to really poke and really ask the right questions just to get that. It's not just an automatic thing. And I feel like maybe that's also why the guys on site aren't like understanding the reason why they're doing things because no one's telling them. Like, how could they possibly be expected to know?
I'm wondering if that's a salesperson versus a technical person issue. Like, these suppliers are employing salespeople as the industry facing touch point.
Yeah. And there's not like a requirement or an expectation that they're going to do all the extra work, all the extra knowledge building and stuff like that. So maybe
Mm-mm.
that's another area to
The
make things better.
hardware stores, we're doing some work at the moment with hardware stores, because they sell, for example, wraps, and they have no idea what the difference between each wrap is and what they do
Sure.
and why they're used. So trades go and buy something from the shelf without really understanding the difference, and nothing is pointed out, nothing is explained, and so it just goes on and on like that.
Yeah.
What are the most cost-effective changes or wins for builders to improve building performance that don't necessarily require major redesign? Is it material? Is it a mindset? What do we need to do here?
I feel like Shawn nailed it on the head. Doing an airtightness test
Hmm.
really puts that mindset into place. And like he said, just a roll of tape and a little bit of caring,
Mm-hmm.
that'll get you way above,
Heaps.
redetailing, redesigning, etc. But
You paraphrase my saying,
a
but
little
yeah,
bit, a little bit, maybe a little bit.
it's the PG version.
Yeah.
What one thing that's really overlooked a lot is how easy it is to change glass specs and get a lot of boost in performance from glass.
Sure.
So
Yeah.
low E coatings on glass in your glass spec, no changes to details. It's usually like the glass company can give you quotes like over the phone. It's really easy to quote.
Mm,
And you can get like, you can improve your energy efficiency by 20, 30, 40% just by changing glass.
sure.
Even in existing buildings, changing out glass can be huge benefits for thermal comfort, particularly, but energy efficiency as well. So
Mhm.
if you're a builder and you've got a set of plans and your homeowner says, I want to build something better, glass, easy, super easy
Mhm.
to improve glass.
Yeah. Because that low E coating will improve the R value of that window, like reflecting heat in, but also you can use it as sunscreen on in, hot sun facing elevations to make sure you don't get as much overheating during the summer.
Yeah. And
I'm
depending
I'm
on in double glazing as well, you can have there's the two panes of glass and there's four surfaces. The outside surface of the external pane, the inside surface of the external pane, and so on. 1, 2, 3, and 4.
Yep.
And those low E coatings on a double glazed pane are on
Mm.
surfaces 2 or 3 in the middle. And that will either reflect heat back into the house or it will reflect heat out of the house. Right? Is
It
that how it
does.
works?
It does, yes. But I would say like the material of the low E coating itself is much more of an influence than just the
As to
surface you're
where it
putting.
is.
Yeah,
Mm-hmm.
like
Mm-hmm.
like surface 2 is generally for blocking sun and surface 3 is generally for reflecting it inside, but
Mm.
if you use the wrong low E coating, because there's hundreds, thousands of different types of low E coating,
Yeah.
um that is much 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 more of an influence.
just
Mm-hmm.
a point of order. It's not reflecting the heat. It's
Sure.
Beg your pardon.
actually it's actually stopping the radiation from the glass
Sure.
and going
Yeah.
inwards or
Yeah.
outwards. I'm actually sort of maybe I'm not surprised that most of Australia wouldn't have low E as the standard specification.
No, it doesn't. I mean, no. Single
Is
glazed. No,
air
no,
conditioning is your standard spec?
yeah.
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 The coatings on windows, yeah, double glazing aluminium frame not double glazing, single glazed aluminium frame windows are still standard in like in the Adelaide Plains in particular. I think that's still happening. Our building code changed a couple of years ago, and the requirements did increase a fair bit.
Mm,
So I would have to make sure of what I'm saying here, but yeah, I think that there's a massive misunderstanding around what double glazing or low E coatings and all that, what they actually mean. People think that double glazing, there's one step of double glazing and that's all there is to it.
sure.
Oh, I've got double glazed windows. Okay, that doesn't mean much. I need more information that will tell me what that actually is going to do to your building.
Yeah.
Um,
Do you also find that people still conflate tinted windows with low E coated windows? Because I've been in meetings where I suggest a low E coating that is basically clear. There's like a slight tinge of maybe
yeah.
green or blue, but
Mhm.
it's not dark like a tinted window that we would be used to from, an office building from the 1980s, let's say.
Yeah.
Um, like everyone knows what that is. Low E coating is not that. It is very much not that.
Yeah.
And so is
Yeah.
that whole
Often
thing in
you can't see
Australia,
it.
that fear.
I think there's a fear, not so much that, there's a fear that low E coatings will scratch and they'll be ugly and those sorts of things. There's
Oh,
like, yeah,
if it's
there's
on a
that.
single glaze, then sure, I guess that's a
Yeah,
reasonable fear,
yeah, yeah,
but it
there's that.
shouldn't. Yeah. Mm,
But yeah, I haven't worked in energy efficiency compliance in a few years now, so I'm not actually sure what 100% what's being specified. And the windows that I work with in my part of the industry they've all got low E coatings on them, and they're all
fair.
UPVC and all that.
I've
So
had a few situations where I've suggested a low E coating, and the mechanical engineer has said, no, we can't use low E coatings because that causes overheating. And I had to
right,
really kind of sit with that and understand that and trying to figure
yeah.
out like why that is. And it's
Yeah.
because, sorry, go for it.
It's worse, Peter. I've had projects where we were proposed to switch from clear double glazing to single glazing to let the heat out.
Yeah, I've had that one too. Yeah. And like, I see what they're getting at because they're looking at it through a very small lens. They're saying sun come in, heat must go back out, as opposed to maybe block some of the sun coming in first
Yeah.
and have a low E coating that blocks out a certain percentage, because there's like different strengths of low E coating. And so if you have a very low strength one, it lets lots of heat in. If you have a really high strength one, it blocks a lot of that heat and reflects it back out, or keeps the radiation out. Sorry, not
You can say
not
blocks.
reflects.
It's fine.
Yeah,
It's
yeah,
a safe space
yeah.
here.
Yeah, but yeah, so it's really just the education
It's
aspect of
perception
this.
and lack of understanding that's
Yeah,
really our
and trying to understand why they're understanding it that way, and then
yeah.
kind of saying, "Oh, I see what you mean. This is the other thing that I mean," and that usually
Yeah.
kind of goes well.
Yep.
The other
Communication.
pushback I get on low E is that they want the solar heat gain in the winter.
Ah, yes,
I hear
Yeah.
that one a lot.
sure.
Yeah.
I have to point out that half of the year it's dark and there's no sun,
Hmm.
and the other half of the year is winter and it's cloudy a lot.
Yeah,
And so you're really trying to design for like 25% of the year. You're gonna not have a good time doing that. So you're
yeah,
best to just block out the sun and use efficient heating systems to make up for it.
yeah,
In heating dominated climate, which is most of New Zealand for sure, and most of southeastern Australia as well.
Yeah.
yeah,
Yeah. A lot of the more higher performance builders, that's where they are. They're
yeah.
in that part where it's cold.
And we're not trying to say like just use heat pumps to fix everything. Like ideally design a very efficient building, but if you're choosing one or the other,
Yeah.
heating is the more effective choice.
Yeah, for
Mm.
sure. So relationships between architects and builders. Architects and builders don't always have the greatest relationships. So what's your experience with that, and how do you think that can be improved?
Mm. I find that we're usually in the middle.
Yes.
And that's generally where we thrive, honestly. So I try to understand it from both sides, because I try to understand what the architect is looking for aesthetically. And sometimes I think it's crazy. Why are we doing that? You're making your life so much harder. But I have to understand the look that they're going for and the reasons why they've gotten there. And then on site, I have to understand the difficulties of installing certain things. Certain membranes are really thick and tough to deal with. So if you have a tiny little corner, you're going to have a tough time. And trying to explain that from one side to the other is kind of where I
Being the
try to
mediator.
work. Yeah.
Everybody calm down, use your inside voices.
Yeah. We're looking at this from two different perspectives. Let's see where there's something in the middle. And sometimes it helps making jokes. Like I'll go on site and like, I don't know, these architects, who knows what they're doing. And then,
Yeah.
During a site meeting, like, no one on site is going to be able to build that. And you just have to try to keep it light, keep it fun.
Yep.
Sometimes it works, sometimes it doesn't. But Shawn?
I'm reminded of a great quote, which is everyone's got a plan until they get punched in the nose, the face, the mouth,
Mm-hmm.
Mike Tyson quote.
Mm.
And that's how I think about architectural details, right? Those are the plan we have going in. This is what's, and hey, builder, you guys are the guys building it. If you've got a better idea, then let's hear it. Let's change it. Let's update the details.
Yeah.
There's no dramas about doing that. And I think so. But builders also need to understand why it's been drawn a certain way. And so sometimes I think, that conflict comes from this is the way we've always built it versus this is the way I've drawn it. It has to be built exactly like it's drawn. And both those sides need to relax a little bit and say, hey, we're on the same team here. We're trying to see the same outcome.
Yeah.
And so if you've got a better way to build it, if you want to change the detail, let's work together to find the best outcome for the project.
Yeah.
It's really the only way I've seen it work. Yeah.
Yeah. I find that using the right vocabulary also helps. Like builders have a certain set of vocabulary and architects have a certain set of vocabulary.
Yeah, everyone has to feel heard and understood, and
and sometimes on site there has to be a few, swear words and expletives, because that kind of works. And then in the architecture world, you have to talk about things like shadow lines and things lining up with each other on different sides of different things and sharp, crisp lines and this and that. So you have to understand both those things.
Yeah, so you could be a real chameleon in this role.
A little bit. Yeah. It's fun though.
But you can't underestimate the how important a mock-up is for key details as well.
Oh my God,
yeah. If you've got every project, your window install detail is always different, always complicated. There's lots of steps involved.
Yeah.
If you're an architect, don't ask the builder to build it and then show up and tell them it's wrong.
Mm-hmm.
Block yourself out an afternoon, go and work with them, help them cut tapes and, stick stuff on and like get your hands dirty,
Yeah.
understand how it's actually going to be built.
Mm.
If that afternoon you spend on site, it'll help you understand how you're going to draw the next building a lot better. It'll build that relationship with that builder, like instant, like your time spent there will be
Street cred.
returned for you tenfold on that project.
Absolutely.
Yeah, I think that's where a lot of it goes wrong is the clean clothes guy shows up and said you did it wrong.
Yeah.
Get out.
Go get your hands dirty.
Yeah.
Go get your hands dirty. You will learn so much more by being there. And you will be a better architect for doing it.
Absolutely.
Builders, same thing. You need to understand the principles behind that detail. Why are we doing it like that? And ask the question, like, not in a passive aggressive way, but just say, hey, help me understand why we're doing it this way. We did it this way last time. So try to understand why the detail is drawn a certain way. And then figure out the right outcome, and everyone will get better from doing that.
Yeah. Like, what's the point of this? What is this supposed to look like? And then that contractor can say, I can build it this way. Does that make sense? Does this work for you? And then good conversation back and forth.
Yep. And do you find that do you have any architects, like the relationship between the architect and the builder is so important, but there are a lot of architects that still they'll do a design and they'll pass it to a builder and they're not really talking. Do you see that much? And does that work? Nope.
The worst sites, the ones where there's a lot of fighting back and forth, finger pointing back and forth, and just a lot of stuff that needs to be fixed is generally those sites where they're not talking to each other, or if the architect did a design and then they definitely have nothing to do with construction. That's when problems happen. But the ones where everyone's trying to work together, that usually works the best, in my opinion. Not sure if you have a different experience, Shawn.
No, I mean, I've got a handful of example, I guess, where the relationship didn't get off to a great start. And in some cases it's not necessarily a personal thing, it's like contractual thing, like the builder underbid the project by a lot. And so now they're starting to chase variations and extras to try and pay their bills, and hey, fair enough, but you get into that sort of situation where there's something else going on. It's never about the detail. It's always something else.
Yeah.
Very fair.
So going back to water in construction, we all know that buildings hate water. So where do you think which is the bigger risk to a building right now? Is it condensation or is it water ingress, like bulk water?
I mean, bulk water is always going to be your highest amount of water.
Yeah,
for sure. So in terms of like acute risk of decay, you're going to get that from bulk, rainwater. Condensation doesn't tend to result in necessarily decay of elements. It tends to result in mold growth. And so when you're doing forensic investigations, you can sort of differentiate between things which are acute outside water is usually very isolated and very decayed, and condensation is usually very widespread and not heavily decayed, at least in the climates that I've worked in. It may be different in certain climates, but definitely like the in-service risk, those are the in-service risk. The in-construction risk is an interesting one, though, with especially mass timber. And this is a lesson learned for everyone in Australia, that Vancouver is screwing this up really bad. To the point that there are consultants that are not working on mass timber buildings anymore because they've had so many legal disputes, construction delays due to not understanding how mass timber is different than stick frame, light gauge steel buildings. They're very different animals, and you need to have a really good weather protection strategy in place if you're going to be building mass timber. It's not hard to do beforehand. It's really hard to fix afterwards.
Yep. Yeah. So you're talking about CLT. You're talking about getting on, first thing that comes to mind is getting on a peel and stick membrane ASAP once that structure goes up.
One option.
There's a few different things to think about, and there's no right answer. Peel and stick can be the right answer for certain projects.
Okay.
We're now starting to see a lot of uptick in prefabricated facade panels being expedited in sequence with the CLT panels, so that those were only exposed for a few days at a time. And CLT can handle a few days of wet weather. It's when you get weeks of wet weather that you can have some real problems.
Yeah.
Um,
So
And
that's when
so
it
there's
soaks in and really takes hold.
Yeah, and the difference is the drying. How much wood you have to go through to dry out that a 200 mil thick piece of CLT is going to take like 5 or 6 years to dry out.
Yeah.
If it gets wet, in the middle.
Yeah.
Versus a standard 4x2 can dry out in a few weeks, few months kind of thing. So just understanding that difference can be huge.
Yeah. And like you said, peel and stick membranes, that's one way of doing it, but that doesn't magically fix the problem because all the joins between have to be sealed up. Any penetrations, you got to sweep off all the water so it's not just going to percolate and absorb through.
Yep.
One idea that usually works for like smaller footprint sites is just having a tent that grows with the building or just sits on the top of the building to keep the water out. That's a really great way to do it. It kind of depends on how the building's built. But it's not only CLT and timber structures that are an issue. Like we've had a few buildings where concrete structure absorbs a bunch of water and then they put the linings on too quick.
Yeah.
That traps a bunch of moisture in. There's no ventilation and heating to dry it out. That starts to cause mold issues and other things in the timbers that are inside and stuff like that. So construction moisture is a huge thing that a lot of people don't really necessarily think about because if you're going more airtight, it traps in more moisture, even though you're trying to trap in the energy. But back to the original question, condensation versus regular water or like water leaks. Water leaks, like Shawn said, are much more wrought, acute things, big problems. Whereas condensation risk kind of takes time. It takes 5, 10, 15 years in a nice warm climate like here. And it's not like the whole building falls over, but things just start to not feel right. And it's hard to ring the alarm about that if everyone's just used to that and it's all okay. So it kind of takes changing people's perspective on the matter and noticing that like mold growth and different things like that are actually a problem as opposed to just inevitable and how buildings always are, which is what I'm trying to always have that conversation about with friends, colleagues, anyone on the street that will listen to me, etc. Condensation risk is a risk. It's a bad thing. It's not just inevitable.
Yeah, I think there's I mentioned in the question two types of moisture issues, which is condensation and bulk ingress, whether that's rain or whether it's a plumbing leak. But the third type, which you both brought up, is the construction moisture, and this one, in my experience, is getting the least amount of attention. And builders are very blasé about it. Oh, it'll dry. I've had builders say that to me. And in some cases, in some cases, no, depending on what happens on site, depending on the season, depending on delays, depending on lots of things. But there's a site here in Adelaide at the moment. There was the builder went bust. The 10 townhouses were left out in the weather for 2 winters, maybe more. Ooh. And the frames are black and now it's being finished and people are going to be living in those townhouses in the not too distant future. And that can happen on a passive house as well. A certified passive house has got zero condensation risk. And they often detail their WRBs meticulously so that, drying can happen and water ingress is not a massive problem, but they can still get wet during construction. They can still go moldy. And they do go moldy. I've seen it happen, not locally, but in other states. And that construction moisture risk, in concrete and in timbers from the rain, that in my experience seems to be largely overlooked, but it's a massive source of moisture.
It also doesn't matter. Like a lot of people say, oh yeah, just leave the windows open and let the air in and that'll dry it out. But if your exterior air is, 14 degrees and 90% relative humidity, there's not a lot of drying that's going to happen unless you put heating, fans, dehumidifiers, and things like that to dry out that air.
And some builders do that, but most don't.
Yeah. Most don't. Yeah. Like I've suggested that on site and got the craziest looks. Like, what are you, crazy? I'm not going to bring a heater on site. How? And so
But that's what
You
happens
mentioned,
when there's a water leak. The mediators will bring in heaters and they'll bring in fans, and that's what they do to dry out buildings quickly.
Yep.
Mm.
you mentioned
Should
that
happen after construction.
condensation.
Sorry.
That condensation risk in passive house is usually modeled and taken care of by the
Yes.
designing professional.
Yep.
But that assumes the building is occupied. It's heated
Yeah.
and ventilated. So
Yeah. And so does
if
all the
you,
heating stuff as well.
yeah, so if you're not,
Temperatures.
if you have built the enclosure of the building and it gets delayed or stops or whatever it is, and you've got water inside the house and you don't turn on the heating and ventilation for a long time, your model is not going to be the same as what you think it is. It's not going to dry out like the model says.
Yep.
Mm.
Yep. 100%.
Yeah. Not everything's perfect, and it relies on us.
Yeah.
It depends.
Mm-hmm.
It's a really interesting topic, the whole moisture thing. It comes from so many different places, and it is the one, apart from fire, which is heavily regulated and heavily, with the exception of massive disasters like Grenfell and like what happened in Melbourne.
Sure.
It is heavily regulated, heavily checked, and we don't want buildings to burn down or fall down. Those things are important and they are focused on. But energy efficiency, less so. It's not as important to immediate human health. And construction moisture, I just feel like people just assume stuff is going to dry. So this moisture issue is just, it's not easily solved, I don't think.
Especially if you're not looking at the realities of how dry and what needs to be done to make things dry, and putting in the time, effort, money to make that happen, or putting in the time, money, and effort to educate people around the industry to understand those things, and putting regulations or specific checks in place. Like, it's us that are, we're discussing it here because we care about it, but not everyone cares or knows what they don't know. So
well, hopefully after listening to this episode, somebody extra will care.
Well, the thing is, like, the way people have been building for 10 or 15 or 20 years has been working for them.
Sure.
And what we need to be careful of, though, is as insulation values change, as we get new technology, new materials into these buildings, the way it's always been done may not work anymore. And so that's why we have this kind of, a bit of caution going into things and say, this isn't the way things have always been built. This is a little bit different.
Yeah.
And you can't just go into it and hope it's going to work out.
Yeah. Heat, air, and moisture is the way it works is changing because of energy efficiency requirements, climate, all that stuff.
Well,
where do you see the future of high performance building going in New Zealand and in Canada? Do you think there will be any of this will become standard practice, or do you think we're still and will remain in this early adopter
I had a
phase?
thought from the last question that kind of relates to this question as well. In New Zealand right now, we're kind of in this middle stage of, we had old buildings that worked really well, but might not have been super comfortable. Like the old villas and stuff like that, gigantic fireplace, you're running the fire all day or all night, and that is, making airflow happen, drying things out, etc. And those buildings worked. They had like really durable timber, et cetera, et cetera. You can't argue that they don't work. They're just not very comfortable or energy efficient. Now, the other side of that is passive house type stuff, where you're doing the modeling, you're doing the thermal bridge modeling, you're checking for condensation risk, you're doing the airtightness, you're doing the ventilation, heating, blah, 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 blah. It's a fully designed system that really works. Where we are currently is this middle section of trying to piecemeal upgrade some R values here and there, trying to wait for the industry to kind of respond to that by providing products and simple off-the-shelf things. But we are very much in the early adopter stage, and the early adopters are doing the passive house stuff, or just doing, all of the things that you would do for passive house, but maybe not meeting a certain energy level, hypothetically. And so early adopters do that, but I don't want to be too pessimistic about it, but it doesn't feel like we're on that path in New Zealand yet. It doesn't feel like we've gotten all of the building code clauses talking to each other. It doesn't feel like there's requirements to look at all the things like ventilation, heating, and other stuff that you would do for a passive house. It's not required to do. It's just consider, and that's your tick box as long as you thought about it, as opposed to doing something. So we're not quite there yet. And we're going in the right direction, and the industry is learning and people are asking more questions, but there's going to be a lot of people in the industry that are just not ready for that yet because there's not knowledge yet.
Yeah.
Yeah, when I look at New Zealand housing, we've got a really interesting climate in New Zealand, and it's so mild and so friendly that if you look at average energy consumption in New Zealand houses, probably it's very similar in most of Australia too. Like you're already at a very low and total annual heating bill. So like your energy payback of going more than what we're doing now is very hard to register on an individual an individual homeowners and to struggle to see the difference between an R4 and an R6 roof because it's going to be 10 or $20 a year kind of thing. So
If
yeah, the trajectory is always going to be towards higher performance. I can't really see a place where the public would accept going to a lower total performance. We just had a bit of a rollback in thermal, not rollback, but sorry, people are calling it a rollback. It's a
yeah, they're getting
change in
rid of
philosophy. It's a change in philosophy, I think. So I think we'll continue on that trend. It's just how fast that curve's going to come is it's not going to be driven by people like Peter and I, because it could never go fast enough for us.
Yeah.
It's going to be driven by the group home builders, the people who are building 3 or 4 or 5,000 houses a year. They're the ones that are going to say this is what we can build for an affordable price. Unless a government gets elected on a mandate to push something faster, it's going to be driven by industry and their appetite to build better.
Yeah. And one way that it's kind of worked is like in Vancouver, the step code where they're kind of future planning the changes in the building code. That's a really great way to do it because everyone can get ready and they can understand what they want to do. They can start doing that early because they know that's eventually going to be the building code and they don't have to worry about, oh, did I accidentally do too much? And then they changed what the trajectory was. You kind of
But
know.
that had the builders on board. Like that was the thing. Builders were on board with that from the start, which is why it got traction and why it's at where it is. Whereas New Zealand, it was top down. So BC Step Code was started in 2010, I want to say, and it was a sort of a 20-year plan to get to net zero by 2030 was the original sort of goal.
Energy
and
efficiency.
And it was plotted out and everybody knew about it and they could get ready. See, we've got stuff like that here. We've got not really. We've got papers that were written by really smart people with recommendations, but they're buried. No one knows what the recommendations are. And the building code is actually following those recommendations, but nobody knows what they are ahead of time.
Of course.
So no one's on board. Everyone's confused. Everyone's playing catch up.
And it's always a reaction. And so when the industry yells out and says, we don't know how to do this, I have to sympathize. I have to, because
totally.
No one's telling you what to expect. How could you possibly expect it?
Yeah.
So in New Zealand, we have this. It's called the Building for Climate Change Roadmap or Plan, or whatever you want to call it. This is the thing. Builders stuffed this up because the plan was actually pretty good. It was really clearly laid out how we're going to get from here to net zero in a very reasonable time frame, like a 20 years kind of thing. And all the builders could have done is said, cool, we know exactly what's coming. We're going to prepare our pipeline ahead of time. We're going to know exactly how we're going to build 10 years from now and never have to worry about the government screwing with them.
Yeah.
Instead, they waited till the last minute, got all upset about it, threw the toys out the pram. And now nobody knows what's happening. Now you have this uncertainty in the plan. Now the thing that was a certainty, you've eroded. Now there's no certainty.
Yeah.
See, you shot yourself in the foot. You should have stuck with the plan that was there because it would be really hard to change if you got on board with it.
And if they wanted to engage with it and kind of get on board with it, the best thing that I could recommend is ask the questions. How do I make these walls this efficient? How do I put a ventilation system in place? We don't have these materials in this country that are cost effective and ready to go. Government, please go find contracts or give incentives to make this work. Like actually, engaging with it and saying, these are the problems, let's solve them, as opposed to waiting till the last minute saying, no, we can't do that. And then it all gets rolled back.
That's just
Well, there's
humans.
also the other thing that that Vancouver did quite well was incentivizing your energy upgrades by giving you development waivers.
Ooh, yeah.
So let's say I had to build to a step 3 as my energy code. You say, well, I'm going to build to step 5, but I want 3 more floors in my building.
Mm-hmm.
And the city was able to say,
yeah.
yeah, cool, we'll play a game with that, sure.
Because they can
So
make more money, and it makes sense for
I don't
everybody.
think there's
Money.
I don't think there's quite the latitude to do that in New Zealand. Formally,
Yeah.
I think probably informally you got some negotiations with council on
Sure.
what we're trying to build here, and could you give us a bit more flexibility because we're going to build better than you expect. But
So that's
other
really thinking
jurisdictions-
outside the box.
Yeah.
That's some really forward thinking. Really getting creative. Really, investing, being helpful. I have not seen evidence of that. We do have a roadmap here. What's it called? Roadmap.
But I think
It's
it really
like-
comes down to collaboration and the government entities and the builders and the designers all working together to get somewhere, as opposed to seeing councils as a roadblock or councils seeing designers and contractors as trying to pull the wool over their eyes or something like that. If we all know what the roadmap is and what the actual things are, and there's a full process, we can all work together and we don't have to worry about uncertainty, because that's
So
really
as
what increases cost.
As a different development philosophy,
Mm.
if you thought about an area of land having an allocation of resources per year,
Sure.
so your 1 acre parcel in downtown Adelaide, you would expect a base building code to use this amount of energy, this amount of water. And if I could find a way to use that same amount of resources, but in a much taller building, then you haven't really done any detriment to anybody else.
Yeah.
Mhm.
And so why not have some sort of policy or, a little bit of balance around that? It seems like a great way to go.
Well, that would take a massive shift for us to be that. I mean, we do have performance solutions for things in our building code, but yeah, to be that flexible, I think would take a bit of a shift.
And there has to be the pathway and there has to be the surety for that, because right now, like when we want to try to do something that's a little bit strange, we have to explain to our clients that, hey, we're going to go put this in front of council. They might say yes. We might have to answer a bunch of questions because it's so new and they don't really understand it.
Yeah.
And that's a lot of times the worry and the pushback.
It's kind of drag.
Yeah. Slowly but surely we get there.
Yeah. All right, guys. Did you want to add anything to that, Shawn? No.
Good.
All right. I think we'll get to our final question now, which is the same question I ask everybody who comes on the show. And that is, if there was one thing you want the listener to know from everything that you've learned in your career, what would that be?
All right. So if there's just one thing I tell my young staff now is don't believe anybody. So first of all, even the stuff that you say yourself to other people, you need to understand why you think that. And is it your opinion or is it a provable fact?
Yes.
Because most people will give you their opinion on something and you need to understand what's their factual basis for it.
Yes.
And their motivation.
So it sounds very pedantic, but even the most basics of things, somebody tells me, I want to understand where's that coming from? Why do you think that? And where can I go read some independent research to prove that?
Yes.
That's very wise.
I was going to say a very similar thing to that. I was going to say, always question the things that you know, because sometimes there's things that you don't know that you should know. And so that really ties in very much. So yeah, don't trust anyone and don't trust yourself either. Always, trust yourself to a certain extent, obviously, but
yeah.
Make sure you fact check yourself and go find actual evidence of that.
Don't assume.
A really helpful thing that we've done at Oculus is when somebody asks you for an opinion or how I'm going to do this or whatever it is, instead of giving you the opinion, you want to reference a third-party piece of research or something. You say, so then it becomes like, I don't know, but here's what a bunch of other people have said about the topic, and they all seem to agree, and I sort of tend to trust them. So
Yeah.
it's a really interesting way of thinking because it's really hard to argue with or against,
Yeah.
I guess.
Yeah.
Yeah. I like it.
Yeah.
I shall take that on board myself too. I think I do that because I think I have been wrong on a number of occasions or been questioned, and I hate
Sure.
that. So I think I lean towards, referencing codes, referencing standards, referencing research. This is what they think, and I think that I agree, and I think, yeah.
It's like when you put something in Chat GPT and it gives you an answer back, then you need to go and verify that answer is actually an answer.
Go to
Yeah.
the source.
I do that with people now.
Yeah.
Because chances are they put in Chat GPT and that's where they got their answer from.
Yeah.
How quickly did the world change once Chat GPT came on board?
Right.
Oh my goodness.
Yeah.
All right, guys. Thank you so much for your time. This was a fantastic, interesting, enjoyable chat. And I'm glad you put aside some time in your day to come and hang out with me.
Yeah. It's been great. Thank you.
That is all for today. Thanks so much for tuning in. There'll be another episode in a fortnight, so if you would like to listen into the types of conversations that I have all the time, please subscribe on your chosen platform. Rate the show, leave a comment, whatever you like, share with your friends and family. I'd love for you to spread the word about the Building Sciology Potty. There's a link in the episode description where you can head to a landing page, and there are some show notes there with relevant links and a full transcript of the show as well, and also links to my socials. So if you're not already, I'd love for you to follow along there too, as I share lots of building science and building biology tips. Thanks again. I'll be back in 2 weeks, so until then, happy healthy building.